Go ahead and let me know if you guys can actually hear me and see me. Please comment if you can see what's on the screen and if you can hear whatever it is that I'm saying. I'm really excited. I'm really excited today because we have TikTok Live Studio. We're now going to be using TikTok Live Studio to show all the work that we're going to do. Hopefully it works out. Hopefully my computer doesn't crash. It doesn't look like it's using too much of the system. But again, let me know if you can hear me. Let me know if the sound quality is okay. Let me know if everything is good to go. So I'm going to go ahead and remove this. Awesome, Harry. Oh, that's exciting. And now you're done. On to the next one, right? So now you're going to take calculus, hopefully. Awesome. Noel, thank you so much for letting me know that you guys can hear me perfectly. Okay. What's going on, you math nerds? Hope you're having a fabulous day, afternoon, morning, wherever it is that you're tuning from. My name's Miguel, also known as the Vegan Math Guy, and today we are going to do AP Calculus Free Response questions. I have 4 questions that hopefully, it says we have an hour limit, and I'm going to do them within an hour. And if I finish them off, then I'm going to go ahead and do other problems. But just so you know that I do record these and I will post them on my YouTube channel. So if you guys have to leave for whatever reason, you guys are more than welcome to look at them later on. I'm really excited today because we're using TikTok Live Studio and I'm hoping my computer is not crashing. It looks like all systems are good to go. It is using a lot of memory, but hopefully nothing, hopefully it doesn't crash. Anyway, guys, so we're going to go ahead and get started. We have 4 questions, FRQs, and if you look at this and if you can read that well, please let me know. If not, I'll try to zoom in at times, but I'm going to try to fit the entire problem on the screen there. No calculator allowed, so we're not going to use a calculator for any of these questions. So I'm going to go ahead and start off with this first question. This was actually one that I made a video about not too long ago, and I solved, I believe, just part A. So we're going to go ahead and talk about part B and part C. This is the AP Calc AB 2021 FRQ. And let's go ahead and start off with this particular problem. So it says a company designs a spinning tool using the family of the function y is equal to cx root 4 minus x squared. And c is a positive constant. The figure above shows the region of the first quadrant that's bounded by the x-axis. And it gave us just that function. So now that we kind of understood what's going on, so this represents a toy, and it has that particular function y is equal to cx root 4 minus x squared. Not necessarily no real reason why it's created that way, but that's just the equation that they're going to give us. So for part A, they're going to ask us to find the region bounded by the curve when c is equal to 6. So the first thing that we're just going to say, okay, my equation is y is equal to 6x root 4 minus x squared. And we need to take the area of this particular shape. So the very first thing that we need to know is we need to go ahead and find the boundaries of this. And we can already tell that the boundary here is going to be x is equal to 0. We're going to verify that in a second. We just need to find this other boundary over here, which we don't know. So we're going to go ahead and set the equation equal to 0. We have 6x root 4 minus x squared. And we're going to, obviously, in this case, we're using the zero product property. That means that 6x is equal to 0, or 4 minus x squared is equal to 0. So for the first one, we divide the 6 to the other side. We get x is equal to 0, which is exactly what we thought one of the boundaries was going to be. And now we have the other one, 4 minus x squared is equal to 0. So we get negative x squared is equal to negative 4. Otherwise, x squared is equal to 4. And if we take the square root of both sides, we get that. Oh, the screen is cut off on the right. Okay, thank you. Is it the entire thing? Let me see how it looks on my end. I'm just going to double check. Thank you very much. Oh, wait. That's because I'm showing stuff over here. Okay, yeah, I see it's kind of cut off on there. Okay, I'll move stuff on the right. I'll make sure that I'm not writing too much on the right side of the screen. But anyway, going back to this, our x value is going to be just plus or minus 2. But in this case, this is going to be in the positive x direction, so our boundaries are going to be 0 and 2. So now we know, I'm going to put our work on the bottom here. Now we know that we're going to take the integral from 0 to 2 of this particular function, 6x root 4 minus x squared dx. Now go ahead and let me know in the chat what you guys think, which method we have to use in order to solve this. I'm thinking U sub. So someone did say washer. Here we are definitely going to use washer in a second, but for this one we're just trying to find the angle. Ooga beluga, yes. It's a very common question. There's more. We're going to do a lot of these questions. It's going to be the 2021 AB exam. Anyway, going back to this, we're going to use U sub. You don't have to show this work during the AP exam, but I think it's always helpful. So we're going to make the U equal to 4 minus x squared. That makes our du equal to negative 2x dx. And if I divide the dx to the other side, we're going to get that du over negative 2x is equal to dx. And now we're going to go ahead and rewrite our integral here. Let's change our parameters. So initially, we had the 0 value, but we're going to change that. And the way we're going to change it is we're going to use the u. So don't forget that if x is equal to 0, u is going to equal to 4 minus 0 squared. So that's just going to be 4. So that's my new parameter for the 0. And now we have the 2. So we're going to use that same idea. U is equal to 4 minus 2 squared, which is just going to equal to 0. And so now we have our parameter from 4 to 0. And then we're going to go ahead and just rewrite a couple things. We have the 6x, and then we have the u is a 4 minus x squared. And then don't forget, now we have the du over negative 2x. You're going to notice that the x's cancel out, which is really nice. And then the 6 and the negative 2 can divide, and we can put that on the outside. So now we have negative 3. Let's do this in red. So now we have negative 3 integral from 4 to 0 of u to the 1/2 du. Yes, Ooga Beluga, you're absolutely right. Okay, now we're going to go ahead and actually do the, we're going to implement the power rule. So we have negative 3 on the outside, and then we have u to the 3/2 divided by 3/2, and then from 4 to 0. And now we're just going to implement the first fundamental theorem of calculus. I'm sorry. When you plug in 0 into this value of u, that just becomes 0, so we're not really too worried about it. We're going to have 0 minus, or I'm just going to put the negative 3 on the outside first, 0 minus, and then now we're going to go ahead and plug in the 4. So it's 4 to the 3/2 over 3/2. This is the issue with problems, or like with this FRQ, there's not enough space for everything. So I'm going to go ahead and just create some space on my blackboard, and I'm going to make things a little smaller. Give me 1 second. Hopefully this works. There we go. Put it here on the right. Okay, so now it looks like we have negative 3 times, and then now we just got to take that 4th root. So this is going to be, it looks like negative 4 to the 3/2 is going to be 8 over 3/2. And so now we have negative 3 times negative 16 over 3. And you're going to see the negative 3 cancels out. So now our answer is just going to be 16. Easy enough. That's just part A. Okay? Part A is always the easiest one whenever we're solving this type of problem. Let me go ahead and erase the work. And we are going to do the other ones. We're going to do part B and part C. Okay, let's go ahead and do part B. Bear with me, guys. This is the first time I'm using TikTok Live Studio, where now I can add like, multiple angles. I can change the screen if I wanted to. I could add like images right in the front, as you can see. I can do that. I could erase things, so it's kind of nice. But anyway, the experience will continue to improve. But if I'm lagging or anything, just let me know. Evan, one thing that I will suggest is practice as many problems as you can. And I would almost not cram any sort of material the last weekend before the test. So this weekend, you should maybe study a lot. Next weekend, you should just be chilling. Be ready, be prepared for the test. Now, in terms on test day, You know, you see this one problem, for example, part B that we're going to do, it looks confusing, but just, you know, take it one step at a time. Read it sentence by sentence, try to understand exactly what they're trying to ask, and, you know, try to attempt it to the best of your ability. Okay, so let's go to part B. So they're saying it is known that y is equal to cx root 4 minus x squared, and luckily for us, they already give us the derivative. And now they're saying for a particular toy, the radius of the largest cross section is 1.2 inches. And so now we need to find the value of C. So what they're saying here is that you have the toy on top, and this little strip that I'm just drawing represents the radius. And don't forget, this equation, the radius, is represented by the actual equation, cx root 4 minus x squared. And they're saying that the largest radius is 1.2. So we know that this radius is equal to 1.2. But that still doesn't really help us because we need to find the value of C, but we don't even know the value of X. But the fact that they say that this is going to be a maximum, or it's the largest cross section, then that means that the derivative at a specific point is going to be 0. Okay, so that means that if we take the derivative of the function, which is already given to us, we're going to set that equal to 0. So we're going to take the equation of the derivative that they gave us, dy over dx is equal to c 4 minus x, or 2x squared. Trying to erase things over here. Geez, it's giving me so many issues. 4 minus 2x squared to the power of root 4 minus x squared. So they're saying at some particular or some specific x value, this derivative is going to equal to 0, and that's what we need to find. So I set the equation equal to 0 because I'm looking for the largest or the maximum value. And all I'm going to be worried about is when the top is equal to 0. So when is c times 4 minus 2x squared equal to 0? If you can imagine, or if you can think about this, I can just divide the 0 to the other side. So I'm left with 4 minus 2x squared is equal to 0. I can subtract the 4 to the other side. So I get negative 2x squared is equal to negative 4. Let's divide that negative 2 so that we get x squared is equal to 2. And then so now x is equal to plus or minus root 2. Now, which one's going to be correct? There's a positive root 2 or a negative root 2? Well, there's two reasons why it's going to be the positive. One, because in the diagram we're working with the positive x-axis, and at the same time you can have like a negative radius. So it's going to be a positive root 2. That's our x value. So this x value, x is equal to root 2, we know is going to make the radius a maximum. And we know that when we plug it into the equation that I just showed you on the top, that's going to equal to 1.2. So then now what we're going to do is we're just going to go ahead and plug in root 2 into this equation and find out when the value of c that makes it 1.2. So let me go ahead and just create some space on the blackboard here, or on the whiteboard in this case. All right. And don't forget, guys, I am recording this, so when this is over, you're going to be able to look for this video on my YouTube. So if you guys have to go for whatever reason, you guys are more than welcome to revisit these videos on my YouTube channel. So as I mentioned, 1.2 is equal to c x root 4 minus x squared. We know that x is equal to root 2 because that's what we found. So we're just going to go ahead and plug it in. So now we have 1.2 equals to 2 times, or c times, root 2, root 4 minus root 2 squared. All right, let's simplify this a little further. 1.2 is equal to c root 2. And then on the inside of this square root, I have root 4 minus 2. Simplify this a little more. C root 2 times 4 minus 2 on that inside of the square root is just going to be root 2. So we're left with 1.2 is equal to c times 2. And now let's divide the 2 to the other side. 0.6 is equal to c. That is our c value. Michael, how did I know to set it equal to 0? If you look in part B, let me go ahead and just erase our work row here real quick. In part B, they're saying for a particular spinning toy, the radius of the largest cross-sectional. So they're asking for the largest. So when you have the largest radius, that means you have the maximum radius, meaning that's when the derivative is equal to 0. So that's the hard part, to be honest. You kind of have to look at those problems and say, okay, well, how in the world are we even going to understand that? But that's what that represents. When they're talking about the largest cross section, they're talking about the maximum, aka when the derivative is equal to 0. Okay, so let's go to part C. For some reason, it's not working on mine. Okay, here it is. So now we're going to go to part C. So they're saying for another spinning toy, the volume, the volume is 2 pi. So what is the value of C? Okay, so they're saying that the volume of this shape, as it is rotated about the x-axis, is equal to 2 pi. And here is where Harry's going to come in, and Harry's going to tell us that we are going to use the disk method. You can technically say it's the washer method, but it's a very unique, it's a very particular case of it. It's going to be the disk method because it's going to be rotated about the x-axis. So they're saying that the volume, which is found by this equation, is equal to 2 pi. And we already know the radius. We know the radius is just that equation that we have on top. So we know that 2 pi is going to equal to, and by the way, I didn't put the pi in front of that integral. We know this is going to be the integral from 0 to 2, which we already found, of cx root 4 minus x squared dx. Lauren, it fits the smallest, and that means that at some point there was a minimum. But to be honest, with these free response questions, they're not going to trick you on that. If they say it was the smallest, so then we're going to assume that we're going to take the derivative and set that equal to 0 as well. What we found with part B, we didn't know whether or not that was a maximum or a minimum. You're absolutely right, because we didn't test for it. However, for this particular question in part B, they already say largest, so we can already just assume that they're referring to when the derivative is equal to 0, no matter what. If they want the smallest, they will say the smallest, and there is not going to be any questions whether it's the largest or the smallest. It'll just be the smallest. It's a very good question, though. Cadence, this could be AB or BC. You can have both. I believe this part of this was in the BC exam as well. Right now, this is an AB test. Okay, so let's continue actually simplifying this. We need to square this. So we're going to have to distribute the squared to the C and the X. And that's going to give us c squared, x squared. And then we have to distribute that power of 2 into the root. And that's just going to be 4 minus x squared dx. And so now we have 2 pi is equal to pi, integral from 0 to 2. And let's simplify this a little bit, okay? I'm going to go ahead and distribute the c squared, x squared into the 4. Actually, I'm going to do a few things. No, let's just do that because I already intended to do that. I'm going to go ahead and let's just distribute the x squared, and then we're going to pull out the c squared from the top, or we're going to pull it out from the integral, so that we have this real quick. We have 2 pi is equal to pi c squared, integral from 0 to 2, and then distributing that x squared, you get 4x squared minus x to the 4th power dx. So if you see, I just pulled out the c squared because it was a constant, so I didn't really care to integrate that. And so now we can continue. 2 pi is equal to pi c squared, and we can start taking the integral of this. This is going to be 4x cubed over 3 minus x to the 5th over 5. And that is from 0 to 2. So we're going to go ahead and plug in the 2. And that gives us 2 pi is equal to pi c squared. And then we have 4 times 2 cubed over 3 minus 2 to the 5th over 5. And I'm not going to worry about the 0 because when you plug in 0 into both terms, you just get 0. So I'm not worried about that now. Okay, looks like I need some more space here on the whiteboard. So let's go ahead and do that now. For those of you joining, where in the world are we tuning in from? And who is prepping for the AP exam on May 8th? How exciting for all of you. I'm just going to rewrite that last step that we had. So pi c squared, and then 4 times 2 to the 3rd power over 3 minus 2 to the 5th power over 5. Okay, let's continue to simplify this a little further. One thing that I'm going to do, let's divide the pi to the other side so that you notice that the pi's just cancel out. So now what we have is we have 2 equals c squared, and let's simplify this a little further. So we have the 2 cubed, which is 8, multiplied to the 4, that's 32. So we have 32 over 3 minus, and now we're going to take the 2 to the power of 5. That's just 32 over 5. Now we just have to be careful to simplify this. We got to get common denominators. And again, no calculators are allowed. So unfortunately, we have to just, find common denominators here. I'm going to make the common denominator of 15 for both, and then I get 160 minus 96, I believe. And now when we simplify this, we are going to be left with 2 equals c squared, 160 minus 96. I don't want to even try to do that in my head because I can easily make a mistake. 4, and then that's going to be 6. So 64. So 64 over 15. And now, gosh, I'm going to move. This is the issue with the AP exams like this, okay? There's not enough space. But what I'm going to do is, let me just erase our work real quick because we're going to have 2 is equal to c squared 64 over 15. And so now what we can do is we can multiply the 15 and divide by 64. So we're multiplying by 15 over 64. And now we're left with 30 over 64 is equal to c squared. And the final step is to take the square root. And we're technically left with plus or minus root. Let's simplify that square root. That's just going to be 15 over 32 on the inside. So c is equal to plus or minus root 15 over 32. Now again, we have two different options. We have a positive or a negative, but it's going to be a positive because the function is above the x-axis. So c is equal to root 15 over 32. There it is. How fun. Yes, Harry, I love it. Reviewing calc for next year because you just took your exam and I'm sure you'll be ready for it. During the summer, I'll do a lot of calculus review because it seems like there's a lot of people on here that love reviewing that topic. All right, everyone, that was part 3 or part C in number 3. Let's go ahead and erase our work here. And now we're going to move on to this next one. So hopefully I have enough space. You know what maybe I can do, which would be kind of nice. Let's go ahead and just create like a whole block here. Ooh, look at all that space that we now have to write our work. I'll even do this. I think that'll be much, much better. Look at that. Alex, yeah, it's always the case. I think after the exam, everyone gets confused and is just thinking like, what was I doing at that particular step? How should I have solved that one? Let me go ahead and erase. Hold on. Let's go ahead and erase it again. Let's go ahead and make this a little better. Okay, guys. So first time using TikTok Live Studio, and I'm just working out the kinks, but I think I'm getting the hang of it so that everyone can have a better experience, a viewing experience for this. Yeah, Alex, you should let us know what you got on the test. Because even if you get a couple problems wrong, you can still get a 4 or 5. I mean, it's not going to matter. It's a lot of the times it's curved, and the points definitely vary depending on the problem. Okay, so let's look at number 4. It looks like we have a function that's given by the graph. So this is the graph of f from -4 to 6. And then you have the function g, which is going to be defined by this. G of x is equal to 0 to x of f of t. So you should start already thinking, if they give you this particular problem, where g of x is equal to the integral, we know that we're going to be dealing with the second fundamental theorem of calculus. We're going to be dealing with some derivatives, and we're going to be dealing with some areas underneath the curve. Candice, I believe in you. Let's shoot for a 4 or a 5. You know you can get a 3. Absolutely. All right, so let's talk about part A. On what open interval is g concave up? We're immediately talking about concavity, so we know that we're talking about the second derivative of g. Now, g of x is equal to the integral from 0 to x of f of t dt. And they're talking about concavity, so we're first going to find the first derivative. And if you recall, by the second fundamental theorem of calculus, this is just f of x. And then we're going to go ahead and take the second derivative. And that's just going to be f prime of x. So they're asking, when is it concave up? Well, concave up happens when g double prime of x is greater than 0. In other words, when f prime of x is greater than 0. And we have to start thinking, what does f prime of x mean? We're given the graph. F prime represents the slope of this function. So we're looking for when the slope is positive. So let's just go ahead and look at our graph there. And you're going to see that it's positive there where I highlighted that. It's negative after. It continues to be negative and isn't positive again until that line in particular. So what are the parameters? We're going to say that it's concave up from -4 to -2 union to 2, 6. Because those are the x values. That's the interval when the function is increasing, or that's a function, that is the interval when g of x is concave up. In other words, when f of x is increasing. Yes, you are, Joey. May 8th, let's go for a 5. I believe in you. Okay, so now they're asking, give a reason for your answer. This is the interesting part. You're going to get points for getting the interval, so that will be 1 point. And for this one, I'm actually going to look at the answer key for this. You'll get a point for, it looks like you just get a point for the response. So you have to justify it. So we're going to get the interval, but we have to say because, and you can just, you have to say it in a nice, concise sentence, because g prime of x is equal to f prime of x is greater than 0 on the interval from -4 to -2, union 2 to 6, then you're going to say g of x is concave up. Okay, so justifying your answer is just literally explaining why this was the case. Lauren, this is a good question. The answer key does not put the bracket. They put parentheses. I typically just like to put the parentheses because technically at the endpoints, the function isn't increasing. We don't know what it is. So for example, at -2, if you look at the graph, -2 has a circle that's a cusp. It's not differentiable. So we don't know the derivative exactly at that point. So I would say play on the safer side and say that your functions are not, or your intervals are not going to have brackets, or you're just going to have parentheses. Hope that helps. All right, guys, let's go to part B. So part B is asking, so P is the function defined by g of x times f of x, and we want P prime of 3. Okay, so again, P of x is equal to g of x times fx. All they want is the derivative at 3, but first we're just going to take the derivative, and we're going to go ahead and use the product rule because you have two different functions being multiplied together. So product rule, remember, is just the first function times derivative of the second plus derivative of the first times the second function. In this case, it doesn't matter in which order you do it, as long as you make sure you take the derivative of each of them at the same time, or different times. Okay, and then now they want P prime of 3, so this is just plugging in 3 into each function. G prime of 3, and then f of 3. Before we even do that, we need to find out what g of 3 and what g prime of 3 is going to be. Well, don't forget, g of x is equal to the integral from 0 to x of f of t dt. So that means that g of 3 is the integral from 0 to 3 of f of t dt. And if we remember what integrals represent, they represent the area underneath the curve. So what they're asking for is the area from 0 to 3 of the function f of t. So looking at our graph, they're looking for the area of this triangle and then that triangle there. How to grab a drink real quick. All right, so let's talk about, it looks like we have two different triangles. You can say weird shapes, but maybe we can kind of cut this up a little bit. Candace, yes, you can actually just literally Google AP Calculus AB or AP Calculus BC, free response questions, and just put a, PDF on there, and you're going to see tons of them. This is where I'm literally getting all the material, okay? Okay, so let's go ahead and find, like we mentioned, we need to find this area. Well, we need the first area. Let me just kind of erase a couple of things so that we kind of know what we're doing. So we're going to have this area, and then we're going to have this area. Okay. One thing that you could see is if you'll notice that this triangle, the one on top, and the other triangle, the one in red, they're both the same, except that one of them is on top, one of them is on the bottom. So it doesn't matter what the area is, those things cancel out. You can go ahead and find the areas yourself, but I'm just letting you know those are going to cancel out. So that is an area of 0. So all we really have to do is find the area of the blue region. And that blue region is just going to be a trapezoid. I know it's a little difficult to see, but if you were to if you're watching a replay, you can pause the video and you can kind of zoom in. And don't forget that the area of a trapezoid is 1/2 B1 plus B2 times the height. So B1 is going to be -4 plus the second base is going to be -3, and then the height is just going to be 1. And so now I have 1/2 times -7 times 1. This is going to be -7/2. So that's my G of 3. Okay? So I'm going to go back down here, and I already found my G of 3. And this was the longest part, I would say. So we have -7/2 times f prime of 3. So remember, going back to the function, f prime of 3 is the derivative or the slope at x is equal to 3. And luckily for us, that section is just a linear equation, so we can just find the slope using rise over run. You'll notice that you go up 1 over 1. So the slope at 3 is going to be 1. So that's what I put on the bottom for f prime of 3. Plus g prime of 3. Don't forget, we did this in part A. Since g of x is equal to the integral from 0 to x of f of t, then g prime of x is equal to f of x. So g prime of 3 is equal to f of 3. So that's just the y value when x is equal to 3 in the graph. So if we go down to it, you're going to notice that at that specific point, 3 comma -3, the y value is going to be -3. So down below, g prime of 3, we know is going to be -3 times f of 3, which just happens to be actually the same thing. This is just going to be -3. Exposer of low drop top. I'm a liar and a thief. Funny. You are funny. Okay. So let's continue, guys. So now we have -7/2 plus 9. So we just need to make sure to add those together. So that's going to be -7/2 plus 18/2. So that's just going to be 11/2. That's our answer. Candace, continue practicing. You got plenty of time. Guarantee him. The best way that I got my 5 on the AP Calculus exam was just doing as many problems as I can. Okay, up until I would say almost a weekend before. I got so nervous. I was having nightmares that I missed the test and all. But you will do fine. Just continue doing as many problems as you can. That's the best way you're going to continue to explain yourself. Okay, Exposer, you got anything else? Any constructive criticism that you got on here before I kick you out? You let me know, okay? So let's go to part C. So part C is asking for the limit as x approaches 2 of g of x over x squared minus 2x. So all we're going to do is use direct substitution. So this is going to be g of 2 over 2 squared minus 2 times 2. Okay? Mint, what if you don't know how to do the problem? Honestly, try your best. Try to even explain your reasoning. This is why I got this, or this is why, I try to do this. Set something up, because a lot of the times these questions come with specific steps, and you'll get points for specific things that you write. It's supposed to be equivalent to a college class, but sometimes not, and that's not the case. Kush, they will be on YouTube. Anyway, guys, let's go back to this. On the bottom of this, I get 4 squared minus 4. Not 4 squared, I'm sorry. 2 squared is 4. So 4 over 4. So we have 0 on the bottom. We might get 0 on top. And what do you know? G of 2 up on top is equivalent to the integral from 0 to 2 of the function. And we kind of did this in the previous example. You're going to notice that the area underneath the curve from 0 to 2 is equal to 0, because those two triangles cancel each other out. So what we have on top is we have 0. No surprise, we kind of already knew this, especially if they give you a limit problem on the FRQ, it's because they want you to use L'Hopital's rule. So now that we know that we get 0 over 0, let's go ahead and take the derivative of the top over the derivative of the bottom. So the derivative of the top, that's just g prime of x, over the derivative of the bottom, that's 2x minus 2. And let's go a little further. Don't forget, g prime of x is the same thing as f of x. We had already done that in a couple problems. And then now we can go ahead and use direct substitution. So now we're doing f of 2 over 2 times 2 minus 2. So on the bottom, that's 4 minus 2, that's just 2. And on the top, f of 2, all we have to do is go to f of 2 on our graph and find the y value for that. And you'll see that it's going to be negative 4. Boom, that is our answer. Ali, I have yet to see a problem where they tell you that it's where it does not exist. I might be lying, but most of the time, the reason why they're giving you this. All right, chat, y'all let me know. Should I expose her? Dude, if you don't have anything constructive, just don't say anything at all. If the chat wants me to kick him out, I'll kick him out. Anyway, so back to Ali. Yes. Absolutely. So typically they don't give you problems where it's going to be DNE, but it's going to be very obvious. You're going to have, 4 over 0. But typically it's because they want you to use L'Hopital's rule. Okay. They want you to continue to use L'Hopital's rule so that you can find your answer. That's really what they're testing you on. All right. The chat wants you out, Exposer. See ya if you haven't left already. Give me 1 second, guys. Okay. Blocked. See ya. See ya. Anyway, guys, that's the second time I had to ban someone, but oh well. I mean, if you don't have anything constructive, what's the point? We're here to have fun. And by the way, I don't know what he's saying that I with my book sales to sell rosemary oil. Have no clue. Anyway, let's go back to, let's clear this. Okay, that was part C. Hopefully that made sense to everyone. So now let's go ahead and do part D. So now we need to find the average rate of change of G on the interval -4 to 2. Average rate of change. Very common question. Average rate of change is just going to be the slope. So again, average rate of change is going to be the slope. So this is going to be G of 2 minus G of -4, whoops, over 2 minus -4. So we're going to start off with that, okay? I know that there's going to be another question on there, but first I'm just going to go ahead and find the average rate of change, okay? On the bottom, that's just 2 minus -4, so that's 2 plus 4. So you all know that that's going to be 6. And then I have G of 2 minus G of -4. Now we already know, up on top, G of 2 is equal to the integral from 0 to 2 of f of t. In other words, it is the area underneath the curve from 0 to 2. And that is the area of that triangle that I drew, or that I circled in blue, and then the area of the other triangle that I drew there. So that's just going to be, again, if you recall, this is just going to be 0 because the triangles cancel out. One is positive, the other one is negative. So G of 2 is going to be 0. That's what I'm going to write for the G of 2 on the bottom there. Now we have minus G of -4. This one's going to be interesting because G of -4 is going to equal to the integral from 0 to -4 f of t dt. This is where we have to be very careful, okay? I'm going to actually have to scroll up just a little bit. There you go. Okay, we need to find the area from 0 to -4. So that is this entire section here. So what I'm going to do is I'm going to go ahead and cut it up into multiple shapes, maybe just 2 shapes. It looks like we have a trapezoid and then we have a triangle. And the one thing is that you have to keep in mind, this is from 0 to 4. So because I'm moving in the left direction, my area is going to be negative. So I'm just going to find the area, and then whatever I get, I'm just going to go ahead and do negative. Oh my goodness, John. Give me 1 second, guys. Actually, no, I'm sorry, John. I'm sorry. No, not the same Miguel was on Love Island. No. All right, so let's go ahead and find that that area there. Let's start off with the trapezoid, okay? Okay, don't forget that the area of the trapezoid is 1/2 B1 plus B2, and then times the height. So we have 1/2 B1. Let's make it, that's my B1, so that's going to be 4 plus my B2 is going to be this other length over here. That's going to be 6 times my height, that's going to be 2. So then this just becomes 10. And then don't forget, this is going to be negative 10, but we'll take care of that later. And then now we have the area of the triangle. Well, the area of the triangle is just 1/2 base times height. The base is 2. And then the height looks like it's 6. So then this is just going to be 6. So adding that together, it's going to be an area of 16. But because we're going in the left direction, this is going to become negative 16. And so now we have 0 plus 16 over 6. And then that becomes 8 over 3. Michael, this is 2021. Okay, so that was the first section because they were asking you find the average rate of change. And then now they're saying, does the mean value guarantee a value of C where G prime of C is equal to the rate of change? So they're saying, remember the mean value theorem, there's a couple of things, but what they're saying, is there a G of C where G prime of C is equal to 8/3? Well, remember the mean value theorem tells you, okay, well, if you have G of -4, which we found to be 16, and then you found G of 2, which is equal to 0, and because 0 is less than the average rate of change, which is less than 16, and this is true, then the mean value theorem holds. That means that there is going to be a value between -4 and 2 where there's going to be a derivative of 8/3. So that's all we have to say. Okay, that's all we have to show, that because 0 is less than 8/3, which is less than 16, there's going to be a value of C where G prime of C is equal to 8/3. Awesome. All right, guys, this was problem number 4. Let's go to problem number 5. And again, if you're just tuning in, don't forget that we can always look for these replays on my YouTube channel, which I will post at the end of this. I believe I'm going to just be able to download this and then just post it as quick as I can. Oh, this is beautiful. Look at this problem. So much space for us to write as many problems as I can. I'm going to draw another big box there. Okay. Let me know if you can read it. I'm actually just going to check if you guys can actually read it on the screen there. Give me 1 second. Just making sure that you guys can see it. It looks like, yeah, it looks like you can. Hopefully you can. Oh, John, another one. He's probably the same person. And I don't think that's true. Okay, so let's go to this one. They give us the equation, 2y squared minus 6 is equal to y sine of x. And they want us to show that the derivative is that what they gave us. So we have 2y squared minus 6 is equal to y sine of x. And we're going to go ahead and take the derivative. And don't forget, we have to use implicit differentiation. Okay? So let's go ahead and start taking the derivative. So for the very beginning, the 2y squared becomes 4y. But then don't forget, we need to take the derivative of that, or we need to include the implicit differentiation. I'm sorry, because we're taking the derivative in terms of x. And then minus 0, because the derivative of 6 is 0. And then now we do the product rule on the right side. So we have y times cosine of x, that's in terms of x, so we're good, plus sine of x times the derivative of y, which is 1, but then we have to include the dy dx. I'm showing every single step here so that we're not getting confused. So I have 4y dy dx is equal to y cosine of x plus sine of x dy dx. And if you recall from implicit differentiation, okay, if we recall this, we're going to have to move all the values that have dy dx on one side. So I'm going to go ahead and subtract that sine x dy dx to the other side so that I have 4y dy dx minus sine of x dy dx is equal to y cosine of x. And then from here, we can go ahead and factor out the dy dx from both sides or from both terms. And that's what we're left with. 4y sine of x is equal to y cosine x. And now the very last step is to go ahead and divide both sides by 4y minus sine of x over 4y minus sine of x. And then we have dy dx is equal to y cosine of x all over 4y minus sine of x. All right. Now look at part A. They wanted us to show that dy dx is equal to that. And that's exactly what we found. John, yes, I actually did make a profit from my derivative book. I made a profit of what? $8, whatever. And what's the problem with that? I'm selling a derivative book. I'm helping people. Okay, so that was part A. Now let's go to part B. Part B is asking for the equation of the tangent line to the curve at the point 0, root 3. So what do we have to do? We have to use, let me erase a couple things because we are going to need the derivative. It's actually already written for us, which is kind of nice. So don't forget, this was our derivative. So we need to find, because they want the equation of the tangent line, we need the y minus y1 is equal to m times x minus x1. Okay. If you guys can't see the whole question, I'm going to kind of like scroll down real quick. Let me know if you guys can see it now, okay? Let me just go ahead and erase a few things so that we can actually have more space. I know it's difficult because there's like, the question is so large, you know? John, I struggle to pay my bills so bad. You guys, I can't keep the lights on, okay? My internet bill is like through the roof. I need to pay for so much stuff. So, John, if you want to support me, buy one of my books, please. I appreciate it because, oh my goodness, I can't. I'm struggling. Anyway, so y minus y1 is equal to m times x minus x1. Okay, we need the m, which don't forget, that's the slope at 0, root 3. And in calculus, slope is equivalent to saying the derivative. So we're going to go ahead and plug in the 0, root 3 into our equation for the derivative. So we know dy dx is equal to y cosine of x over 4y minus sine of x. So we're going to plug in root 3 for y, 0 for x. So we have root 3 for the y times cosine of 0 for the x times 4 root 3 minus sine of 0. Okay, don't forget cosine of 0 is 1. So on the top, all we have is root 3 over 4 root 3 minus sine of 0. That's just 0. You'll notice the root 3's cancel out, so we're left with 1/4. Okay. So now we found the slope. And guys, if you want John out, I'm so sorry, John. You're just not being productive. Let me know, guys. I will kick him out. Here we go. So we found the slope. And so now we know our x1 and our y1. We know x1 is 0. We know y1 is root 3. So now we have y minus root 3 equals 1/4 times x minus 0. And on the AP exam, you're okay to leave your equation out like that. Okay? It is okay to have it in points law form. You don't have to worry about it. That was part B. As you can see, pretty simple, right? Very, very simple. All right, so let's go to part C. So part C is asking for, on the interval 0 to pi, find the coordinate of the point where the line tangent to the curve is horizontal. Well, this is the equation, or this is the slope of the tangent line. And don't forget, if we have a horizontal tangent line, what does that mean? It means that the derivative is going to be equal to 0. Just imagine, again, we've done this so many times in calculus, but if I have a curve and I have a slope here, this is my tangent line, it's horizontal. And that slope is going to be 0. So what they're asking for is find the values where this is equal to 0. Okay? Now, we don't want the bottom to equal to 0. We just care about the top is equal to 0. 0 is equal to. So now we have y cosine x. Okay, so now we have y is equal to, or 0 is equal to y cosine x. So we're going to use a zero product property. Either y is equal to 0 or cosine of x is equal to 0. But keep this in mind. We can make y equal to 0 because in part C, they want y to be greater than 0. So we know that's not even going to matter. What we care about is when cosine of x is equal to 0. And that happens when x is equal to pi over 2. Okay, so now we know that pi is equal to pi over 2, or the x value is equal to pi over 2. So we want to find the y coordinate for that. We're going to go ahead and plug it into the original function that was up here. So then we have 2y squared minus 6 is equal to y sine of pi over 2. And so we have 2y squared minus 6 is equal to y. Sine of pi over 2 is just 1, so we just have y on the right side. And we have a quadratic, so let's go ahead and bring the y to the other side. So we have 2y squared minus 6. We just need to solve for those y values. Got to bring that quadratic or those quadratics in here. I'm going to use that slip and slide method. Everyone factors this differently. I personally like this method. I'm looking for two numbers that multiply to negative 12 and add to negative 1. That's going to be negative 4 and 3. And then I'm going to divide by 2 because I multiplied by 2 initially. So then now my factored form is going to be 2y plus 3 and then y minus 2 is equal to 0. So y is equal to negative 3 halves or y is equal to 2. Now remember, y has to be positive, so we're only going to use y is equal to 2. So now our coordinate is going to be pi over 2, comma 2. At this point is where our function is going to have a horizontal tangent. Now, it starts off really easy. It starts off talking about, find the horizontal tangent, meaning when the derivative is equal to 0. We found that, but there's a few more steps to that. And obviously, it's a free response question. It's an AP Calc. They're not going to make it super easy. All right, guys, let's go ahead and do part D. I'm just trying to read the comments, see if there's anything that I'm missing out. There you go. So are these solutions going to be posted? Yes. I mean, technically, you know what I'll do? I am going to post a replay on my YouTube on the live, but I will post the link to the solutions of this so that you guys can work on it. I'll post two things. I'll post this file that you see on the screen, and I'll post the solutions as well on the description on that YouTube link. Awesome. All right, so let's go ahead. That was part C. Now we got one more, part D on here. Here we go. So let's see, what are they asking for in part D? Determine whether the function f has a relative minimum, a relative maximum, or neither at the point in part C. Ooh, okay, well, we found the point pi over 2, comma 2. And this is crazy because if you don't get part C correct, then part D you're kind of going to struggle with, which is kind of unfortunate. So we want to know whether or not it's going to be a relative minimum or a relative max. But don't forget, we already know that pi over 2 is the point. So what we're going to do is we're just going to go ahead and test some values. So we're going to do the number line. We're going to test a couple points. This is from 0 to pi. So let's go ahead and do like 2 pi over 3. And then we're going to do pi over 4. And we're going to test the derivative. We're going to plug these values into the derivative. Actually, in this case, if you'll notice, we can't just plug in pi over 4 into the derivative because our derivative has functions in terms of y and x. So initially, that's what I was thinking, just testing points and seeing if it's going to be a maximum or a minimum. So if we cannot plug in x's and y's into this, we're going to go ahead and have to take the second derivative and check its concavity. This is so unfortunate, guys, but we have our first derivative, and we're going to have to take the second derivative. So we're gonna use the quotient rule, and if you recall, this is low times d high, which is dy dx cosine x plus y times negative sine x. Oh my goodness, minus y cosine x. No way, I cannot believe we have to do this. 4y, well now I have to take the derivative, so this is gonna be 4. Sorry, I'm trying to erase that. There we go. 4 dy dx and then minus cosine x. I'm trying to make it all fit on the screen over here. And this is all over 4 minus sine of x squared. This is just insane. So now what we're going to have to do, actually, I noticed that this is kind of off to the side. So let me go ahead and move it real quick. Damn, that's crazy. I really thought that I was going to be able to move. John, that's okay if you don't feel comfortable. You can always just log off. You could always just click bye-bye. Oh, so it looks like I can't move this. Otherwise, it's going to move a lot of my stuff. But here's what I'm going to do. I took the second derivative. The reason why we're doing this is because now we need to plug in that point pi over 2, comma 2. We need to plug that in because we're just going to test the concavity. So we're going to do the second derivative is equal to 4 times 2, which is my y value, minus sine of pi over 2, times, I'm going to have to move this just a little further down. Well, it wouldn't be a free response question if it was easy, right? 4 times 2 minus sine of pi over 2 times, dy dx. Now we still need to find what that dy dx. So actually we know that the derivative is equal to 0 there, which is kind of nice. So we're going to make that derivative equal to 0 times cosine of pi over 2 plus 2 times sine of pi over 2, and then all minus y, or 4 cosine of pi over 2, and then 4 times 0, because that's the derivative minus cosine of pi over 2, all over 4 times 2 minus sine of pi over 2 squared. Okay, this might seem a little daunting, but check this out, guys. In that first parentheses, this is just 8 minus 1. Because 4 times 2 is 8, sine of pi over 2 is just going to be 1. In that second parentheses, 0 times cosine of pi over 2, that goes away, plus 2, so that's just 2. So right now what we have on the bottom so far, or on the top, we have 7 times 2 minus, now check this out, 4 times cosine of pi over 2, that's just 0, so it cancels this entire section on the other side. So really what we have is just 7 times 2. So minus 0 all over, and then on the bottom we just have the same thing, which is going to be 7 squared. And so now what we have is we have 14 over 49. The value doesn't matter. The fact that it's positive, that means that it's concave down, because this is a second derivative, meaning that the function is going to be a minimum. Or I'm sorry, wow, I was already thinking differently there. The concavity is positive, so that means we're going to have a minimum here. It's concave up, so we're going to have a minimum. Oh, John. Who are you, John? I'm sorry. Okay. Sorry, guys. Sorry for the chat. I know you guys, there's a lot of people here that are trying to learn stuff, but over here, he's just, he's going crazy. All right. Anyway, so let's go ahead and break this down. Part D, I believe that was it for number 5. You could, Alex, you could have seriously plugged it in if you wanted to. Yes, you absolutely could have wanted to if you want. Yes, you could have. All right, here we go, guys. Let me go ahead and erase this material. You could have plugged in those values, but you were going to get a derivative 0. Hold on. I'm trying to clear all my drawings here. Here we go. We got the last problem. We got a slope field. Now, in the very beginning, this looks like it's very difficult, but it's actually not as hard as you think. Okay, so we have the function. Let's just kind of read that carefully if you guys can read that on top. So it says the medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by the function. So we have this function, and the derivative is given to us, 12 minus y over 3. And at that time, t is equal to 0, where 0 is, there are 0 milligrams present in the very beginning. Okay, so a portion of the function is given to us, and they want us to find this, or they want us to draw the curve that passes through 0, 0. Now, this one's really simple. All you have to do is you start at 0, 0, and you have to sort of follow the slope field. So if you notice here, the slope field goes this way, and you continue drawing your line to the next slope field, and it's not going to have to be perfect, but you're going to sort of see the shape of the solution. As long as it passes through 0, 0. What they're going to be looking for is they don't want you drawing some random function, for example, like the one in blue. That is completely incorrect because it doesn't cross through 0, 0. So it's not going to have to be perfect. You're just going to have to try your best to draw the best solution for that. All right, here we go. Whoop, here we go. Okay. Actually, no, maybe I should move to part B, or actually just leave it like that. Okay, so that was a slope field. Now in part B, they're asking, using the correct units, interpret the limit of the function as t approaches infinity. Well, if you look at this, as t approaches infinity, look at the curve. It looks, if you'll notice, I'll draw this straight line in blue. It sort of has like a horizontal asymptote. So what's happening as t approaches infinity is the function is approaching 0. So in terms of the problem, we're going to say that as time, or as we go on forever, or as time approaches infinity, the number of milligrams of the medication in the patient is going to be 12. So it's all about just reading the problem again and then just understanding what they're saying and interpreting that. So again, as the time approaches infinity, we are going to say that the number of milligrams in the patient's bloodstream, for example, is going to be 12. All right, so this is part B. Now we're going to go to part C. This is the fun part. This is where things are going to get really interesting. I don't think we need the stuff in the front or on the top here, but we're going to go ahead and solve for part C. Let me go ahead and put like a little rectangle or like a box here so that we can go ahead and do the problem. Okay, so we need to use separation of variables to solve for the function, and then they already give us an initial condition. Whoops, 3 minus y, this is just 3. Oh my gosh, they made it so easy. So they give us the function, this is in terms of dt, and then they're saying that when a of 0 is equal to 0, meaning that when t is equal to 0, the function is equal to 0. So now we're going to go ahead and solve for our function here. Now, separation of variables, what we're going to have to do is we're going to have to multiply the dt to the other side. Let me just do it step by step. We have dy is equal to 12 minus y dt. Now, on the right side, our equation, well, what happened to the 3? There we go, over 3. On the right side, we still have an equation of 12 minus y. So we're going to go ahead and divide both sides by 12 minus y so that we're left with this equation, guys. dy over 12 minus y is equal to dt over 3. And now we're going to go ahead and use the integral. We're going to go ahead and integrate both sides. On the left side, don't get confused. It technically is going to be natural log of 12 minus y. But if you were to use u sub, you will notice that du is equal to negative dy. So negative du is equal to dy. I just wanted you to be cautious of this. So this is negative du over u is equal to integral of dt over 3. And so we're going to go ahead and integrate the left side. That becomes negative natural log of u is equal to 1/3 t. And I'm only going to put the plus c on one side. If you guys have done this plenty of times, you'll know that whenever we add, you're supposed to add the c on the left, the c on the right, but you can just add it on one side and be good to go. Now our u, we're going to go ahead and substitute that back in. So we have 12 minus y in for the u. And I personally like to already plug in the initial condition. So when t is equal to 0, the y is equal to 0. So we're going to go ahead and plug that in. And I'll move my work over here. So we have negative natural log of 12 minus 0 is equal to 1/3 times 0 plus c. And so now we have negative natural log of 12 is equal to just c, and we found our c value. So now we know that our equation, negative natural log of 12 minus y, is equal to 1/3 t minus natural log of 12. Now, let's go ahead and create some space here on the whiteboard because I know that we're going to run out of it. Oh, I hate this. I can't really... Oh, actually, no, I can't. I can't make this smaller because then that's going to make everything smaller. Let's see. Let's try something. You're going to see what I'm talking about right now. Oh, I could make it smaller. Yay. All right, guys, here we go. Oh, great. See, this is my issue. That's what I was worried about. When I made that smaller, it like just brought everything behind this screen. It's okay. I'll put the work here. So we have negative natural log of 12 minus y is equal to 1/3 t minus natural log of 12. We'll take care of that in a second. Yes, Lauren, when they're asking for the horizontal asymptote, they're referring to the numerator. And I've seen problems where they ask for the vertical asymptote. That's the denominator is equal to 0. Correct. Okay. Oh, I guess you guys couldn't see the work there, huh? Let me just rewrite it. Let me know if you guys can see this. Oh, you can't. See, this is what I was worried about. Let's go ahead and I'm going to have to kind of just erase everything and restart it. Zoom is not letting me rewrite this. So let's go ahead and just write the equation down over here. 12 minus y is equal to 1/3 t minus natural log of 12. Okay. So the first thing that I'm going to do is let's go ahead and divide the negative 1 into everything. And I'm going to move the work down here. So natural log of 12 minus y is equal to negative 1/3 t plus natural log of 12. And then let's go ahead and take the e to both sides. So that we're left with 12 minus y is equal to e to the power of this whole thing. And now the cool thing is that you don't have to, honestly, you don't have to simplify this. You can just leave it as e to the power of all that. That is totally fine. We'll subtract the 12. So now negative y is equal to e to the negative 1/3 t plus natural log of 12, all minus 12. And then now divide by negative 1 into everything so that we have our final solution. Negative e to the negative 1/3 t plus natural log of 12 plus 12. That is the original solution. Pretty cool, huh? I love this. Whenever you see a slope field, you should almost smile and think, okay, this is perfect, because you know you're going to have to use differential equations or separation of variables. All right, last problem for today. It is part D. Again, don't forget, I do post the replays on YouTube, and I have a lot more practice videos that you guys can do on YouTube. And just continue to check out my TikTok. I'm posting a lot of content up until May 8th for all you lucky people taking this exam. All right, I'll be here tomorrow as well. We're going to do some multiple choice questions, but I'll post that on YouTube too. And in the meantime, don't forget to like this video. Please follow me on TikTok. Follow me on Instagram, on YouTube. I'm all on there. Awesome. All right, so let's go to part D. So a different procedure is using the administrator. The amount in milligrams of the medication in the second patient is given by this function. So they give us a derivative. At time t is equal to 1, there are 2.5 milligrams. Is the rate of change of, ooh, I love this question, because all they're asking is the rate of change of the amount of medication in the patient increasing or decreasing. Well, this is already the rate of change. This is so common. I've seen this a couple times with some students. And they want us to find whether the rate of change is increasing or decreasing. So in other words, they're saying, is the derivative of this positive, or is the derivative going to be negative? Okay. So what we have to do, unfortunately, is we got to take the satisfies the differential equation. The amount of medication is second. Okay, so B of t is the amount of medication. So again, what they want to find is they want to find the derivative of that. Okay. So let's not forget, B of t is equal to y, they tell us. And dy dt, which is the derivative, is equal to 3 minus y over t plus 2. Now, this is where you got to be a little clever. So they kind of trick you, because obviously every question that's part D is going to be the most difficult. What is my YouTube? Just look for the vegan math guy. It's going to be the same thing as this. Okay, so this is why I'm saying this. You notice how in the dy dt, this is already the rate. We want to find the derivative of this, which we're going to do in a second. But you see that y? That is also b of t. So then we have to rewrite that y value as b of t and then all over t plus 2. So we have to go ahead and take the derivative of this. Okay? So we're going to go ahead and take the derivative of this. The first one is just going to be 0. We're done with that. Minus, we have to use a quotient rule for this. So this is going to be t plus 2 times b prime of t minus b of t times the derivative of the bottom, which is just going to be 1 over t plus 2 squared. Okay, and now they're asking for whether or not it is increasing or decreasing at t is equal to 1. So all we got to do is plug in 1 for t. So we get 0 minus, and then we have 1 plus 2 times b prime of 1 minus b of 1 times 1 all over 1 plus 2. I'm changing the colors there so you can kind of see what I'm plugging in there. Okay, so we have negative 3 and then b prime of 1. Don't forget, b prime is this equation. So if I take the derivative, this is going to be 1 dy dt. So it's really the same equation here. So we got to plug in 1 into that. I don't know why when I'm looking at this, I feel like I'm messing it up, but I wrote everything correct because we took the derivative. So we have here, I'll check this out in a second. So b prime of 1 minus b of 1, which is just going to be 1 all over 3 squared, which is going to be 9. Okay, we just got to figure out what b of 1 is and what b prime of 1 is going to be. Okay. I'm just trying to see. Lauren, that's a great question. So this question comes up a few times because they're giving us the rate and they're asking if that rate is increasing or decreasing. So that is the trickiest part. If you continue practicing some free response questions, you're gonna see that they do talk about whether the rate is increasing or decreasing, and that always means whether the derivative of that function that we found. Because the dy dt that I circled up on top is the rate, and if we're trying to find whether it's increasing or decreasing, we are going to go ahead and have to take the derivative of that and see if it's positive or negative. I know it's a little tricky, but you're going to see that question comes up a lot. So if you look at more FRQs, you're going to see this particular question where they're asking if the rate is increasing or decreasing, meaning in other words, you're going to have to go ahead and take the derivative and check if it's positive or negative. Okay, so I took the derivative here, but I'm just trying to find what b of 1 and b of t is going to be, which they kind of already gave to us at time is equal to 1. So when t is equal to 1, the y value is 2.5. That's what I'm missing. So they're saying that when you have 1, the y value is going to be 2.5, and I think that's going to prove useful for us because now we can go ahead and find the derivative. So if you recall, b prime of t is equal to 1 times dy dt, and dy dt is a derivative that was given to us, which is the one that I'm highlighting in blue. So really what this is going to become is 1 times, and then 3 minus y over t plus 2. So unfortunately, if we're trying to find time is equal to 1, we need to plug in 1 for our t, but also 2.5 for our 2.5 for our y. So now we have 3 minus 2.5 over 3, and we can technically simplify this. This is 3 over 5 halves over 3. You probably don't have to do this. You can really just estimate if it's going to be a positive or a negative value, but I like to actually find the correct value. So this is going to be 5/6. Whoops, 5/6. And so this becomes 13 over 6 if we use common fractions. So now for our value, we have negative 3. And then b prime of 1 is going to be 13 over 6 minus b of 1. B of 1 is just going to be 2.5 all over 9. So if you notice on the bottom or on the numerator of this whole thing, okay, you're going to see that that's just going to be a negative value because we have a negative minus 2.5. That's just going to be a negative value. So it's less than 0, meaning that this is going to be decreasing. Because the derivative is decreasing or because the derivative is negative, the rate at which the medication is being administered is going to be decreasing. And that's what we have to say. Michael, that's a great question. I believe if you don't, I'm not showing, I showed as much work as I can. I always say that's probably the best because let's just say you make a mistake or you do end up getting the correct answer. They're going to want to look at your work and say, okay, well, how did they get it? So I'd say the best case scenario is show as much work as you can. I'm going to highlight this section here. This is me showing, a lot of the work, with like multiplying the 2.5 and turn it into a fraction. You probably don't have to do that. If you can do stuff in your head, great. But the more work you show, the best or the better. All right, guys. So that was the last section. There is a lot more. So what I'm going to do is I'm actually going to show, I am going to start, when I post this on YouTube, I am going to have the link to this particular file. Whoops, sorry, the Zoom showed up here. I'm going to have the link to this particular file, and I'm going to have the answer key for you to look at. Okay, there were 2 questions that we didn't do just because I knew that I wasn't going to have enough time, but I will be back tomorrow around the same time, 2:45-ish. so that we can go ahead and do some multiple choice questions. Next week on Tuesday, I'll be doing the same thing on Thursday, and then the same thing on Friday. So I'm going to try to do as many videos as I can. If you want to continue to support what I do, please like this video, follow me on here on TikTok, follow me on Instagram, follow me on YouTube. All the link is in my profile. And if you ever feel like supporting, like that guy, I forgot who that was, the one that we kicked out, I do have books. And do I make a profit? Not much, but does it support what I do? Absolutely. So if you guys, find it in you to support in any way, I would totally appreciate that. So Lauren was saying most of the times you get a point with the correct answer, one for work. Yes, absolutely. So if you look at the answer key, which again, I'm going to link on the replay on this, you will see where they give you points. So they'll say you'll get a point for writing the equation. You'll get a point for showing work or for showing your justification. Yeah. Thank you, Chris. No, you're the best. You're all the best. Anyway, guys, I'm going to have to head out today. But again, I'll be back tomorrow for more AP review. Please, please, please continue studying. The more studying, the better. You are going to continue to elevate your grade, and you're going to guarantee a higher grade if you just continue studying. The more problems you expose yourself to, the better. All right, everyone, I'm going to head out. I hope you guys have an amazing rest of your day. I'll be back tomorrow with more AP review, and I'll see you guys real soon.